Welcome students. So welcome to the second part of dimensional analysis, and in the first part we have learned how to make dimensional formulas, and now we are going to learn the applications of dimensional analysis. In this video we will learn how to make dimensional formulas for our use, and we will discuss about the merits and demerits of the dimensional analysis. Now first of all, what are the demerits? What is dimensional formula? We have already done in first part. So the dimensional formula is of any physical quantity is converting the system into all the fundamental physical quantity, which is mass, length and time, which we have learned in first video. Now the second part, how we can make a dimensional formula into a dimensional equation. Now if we have a physical quantity x is equal to mLT, then that is known as dimensional equation. And one more thing, there is an important thing for that. We have a principle of homogeneity. Now what is principle of homogeneity? If two-dimensional formulas are equal and they are having different powers, let's say the powers are x, y and z here, and the powers are a, b and c here, then if two-dimensional formulas are equal, then according to principle of homogeneity, the powers of mass, length and time are also going to be equal, which means according to this principle, x is going to be equal to a, the powers of m, and y is equal to b, and z is equal to c. So that is known as principle of homogeneity. If two-dimensional formulas are equal, then the powers of mass, length and time should be equal. Okay, so that is going to be the simple principle of homogeneity. Now we will discuss about the merits and demerits of dimensional analysis. Now first of all, we will discuss the merits and demerits in the short form. Now what are going to be the merits of dimensional analysis? The first is we can convert one system of units into another. Now this is having the meaning we can convert SI into CGS or CGS into SI or any other system of units. We can convert any system of unit into any other system of units. How we can make that? We can take example of that. How we can take example? So let's assume in numerical. We are going to take a numerical. So if 10 Newton, you can say convert 10 Newton into time. Now obviously the Newton is the unit of force. So we are going through some steps. Now first step is that, step 1. So first of all, recognize the physical quantity. Now Newton and dyne are the units of force. So which means we have a physical quantity of force here, and the dimensions of force is mLT minus 2. That we have already done in part 1. How we can make dimensional formula of any physical quantity. Now step second, that's very important. How we can convert one system into another. So with the powers of dimensional formula, you can have the value of, now a is equal to 1, that is the power of m, which means b is equal to 1, which is power of length, and c is equal to minus 2. So now we have to convert 10 Newton, which means the value of n1 is equal to 10. Now we can have a shortcut formula. We can also make that formula. The shortcut formula is n2 is equal to n1 m1 upon m2 raised to power a, L1 upon L2 whole power b, and similarly T1 upon T2 raised to power c. Now, how we can make this formula? That is very simple. We know what is physical quantity, that is equal to any number and system of units. Now, if we are talking about the same physical quantity, so obviously the first number is n1 and the units are m1, you can say, or you can take any powers m1, l1 and t1. That is going to be units in one system. And similarly n2 is going to be, yes, so that is going to be m2, l2 and t2. From that formula we can easily calculate the value of n1. So from that we have easily calculated the values. So in which you can take the powers as a, b and c, a, b and c. So we can calculate the value of n2 from here. So n1, m1 over m2 raised to power a, L1 over L2 raised to power b, and T1 over T2 raised to power c. For a particular numerical, you don't have to go through all this. So just remember this formula, this shortcut formula to convert one system of unit into another. Now, what are the values of M1, M2, L1, L2 and T1, T2? That is most important point here. Now we will move forward to the step third. Now what is step third here? Now what are the values of M1, L1 and T1? Always take note of that. What is given to you, that is going to be upfront as M1, L1 and T1, and what is to be calculated, that is going to be M2, L2 and T2. Now 10 Newton are SI units, which means SI units are given, and convert into dyne, which means CGS units we have to calculate, which means the value of M1, L1 and T1 is going to be SI units, which means 1 kg, 1 meter and 1 second. And similarly the value of M2, L2 and T2 is equal to, now this is all about SI units, this is all about CGS units. In CGS units, mass is going to be 1 gram, length is going to be 1 centimeter and time is going to be 1 second. And with these values, you have to put up these values here and you will have your answer. The value of A, B and C is already with us. A is equal to 1, B is equal to 1, C is equal to -2, that we have derived from the given physical quantity and the powers of MLT. Now N1 is given to us 10 Newton. Now just putting these values in this formula, we have our answer. So N2 is equal to, now what is the value of N1? That is 10. Now what is the value of M1? That is 1 kg over 1 gram and raised to power A, which means the power is going to be 1, and similarly 1 meter over 1 centimeter raised to power 1, because B is also 1, C is -2. And in both the systems SI and CGS, the unit for time is seconds. So 1 second over 1 second. So this is cancelled out. So anything, now 1 is having any power is equal to 1. Now we have to calculate this. Now kilogram means 1000 gram over gram raised to power 1. Now 1 meter is 100 centimeter over 1 centimeter. Now just calculating the powers of 10. Now that is 3 here, 3 0 here, 2 0 here and 1 0 is here. So therefore N2 is equal to 3, 4, 5 and 6. 10 raised to power 6 dyne, which means you can say 10 Newton is equal to 10 raised to power 6 dyne. That's how we can calculate these units from one system into another. That's very easy. So you can convert any system of unit into another system, and this is very easy, and this can be used as a tool for your future prospect as well. in any kind of numerical, if you don't know the units of CGS or SI or MKS, then you can convert it by this method. So I am just going to take another numerical of that in a very short form. So I am just going to take one more numerical here. So if we want to convert, let's say we want to convert 10 joules into erg, which means we are going to convert SI into CGS. You can practice for the reverse of that as well. So which means step 1 is going to be, now check out the physical quantity, joules. So which means either it is work or energy, and they are having same dimensions. So which means energy, let's take energy. Energy is having dimensions of mL2 T minus 2. You can use any formula of any energy, potential energy, kinetic energy. All the energies are going to have the same dimension, mL2 T minus 2. Which means the value of A is equal to 1 now, B is equal to 2 now, and C is equal to minus 2 now. And similarly, the value of N1 is given to us because of 10 joule into erg. So which means, now the step second, just converting M1, L1 and T1. Now what is the value of M1? That is always going to 1 kilogram, 1 meter and 1 second. And similarly M2, L2 and T2. So that is going to be 1 gram, 1 centimeter and 1 second. Now just putting these values in this formula. Remember the tip here, beta. If you want to convert SI into CGS, then CGS is always going to be M2, L2 and T2. And if you are going to convert CGS into SI, then M2, L2 and T2 are going to be SI units. So which units we want to calculate, that should be in the M2, L2 and T2 format in this formula. Now just putting the values here, you will have your answer. So N2 is equal to, now what is the value of N1? That is 10. So 1 kilogram, again the same thing, over 1 gram raised to power 1. Similarly 1 meter over 1 centimeter raised to power 2 this time. And 1 second over 1 second raised to power minus 2. So this is cancelled out because 1 is having any power, this is going to be 1 here. So which means 10,000 from here, now 100 square. So which means 4, 5, 6, 7 and 8. Which means N2 is equal to 10 raised to power 8 erg. So which means we can easily have the answers. So 10 joule is equal to 10 raised to power 8 erg. So this is how we can calculate any numerical. We can convert one SI unit into another. Now we are going for the second part, the second use of dimensional analysis. Now the second use is going to be, now we are discussing applications of or merits of dimensional analysis. So that is the first use of dimensional analysis. Now the second one. Second one is checking the correctness of any relation. So we can check any formula from in this format. So let's take a numerical first. So I am just taking a numerical, just velocity is equal to 2gm upon r. Now the numerical is that, check this formula. So either it is correct or wrong. So first of all, go through the dimensions of left hand side. So that is velocity displacement over time, which means L upon T, which means dimensional formula is going to be no mass here, so m0 LT minus 1. So that is equation number 1 for you. The left hand side dimensions are m0 LT minus 1. Now the dimensions on the right hand side, so which is 2 capital G, capital M and R. So capital G is gravitational constant, and what we have done, the Newton gravitation law, G m1 m2 upon r square. From that we can calculate the dimensions of G, which is going to be fr square over m1 m2, which means force is having dimensions mlt minus 2. R is going to be distance, so which means L square, and here we have two masses, which means m square, so the dimensions of G is going to be m2, and 1 minus 2 is m minus 1, and L1 and L2, so which means L cube and T minus 2. So this is going to be the dimensions of G. Now we can't take 2 here because that is the drawback of dimensional analysis. We are not considering any constants. So just taking the dimensional formulas, m minus 1, L3, T minus 2, and similarly mass. So that is going to be m, and radius is L. So and raised to power half because of square root. Okay. So now what we are having, the powers are m minus 1 and m, so which means m is 0, L3 and minus 1, which means L2, and T minus 2 raised to power half, which means dimensions are m0 Lt minus 1. Now check the equation 1, so it is equal to left hand side, which means the relation is correct, because left hand side dimensions are equal to right hand side dimensions. That's how we can calculate any formula. If any given formula are having this kind of equation, which means the left hand side dimensional formula is equal to right hand side dimensions, then according to principle of homogeneity, so your relation is always going to be correct. So now the third part, the third use and third type of numericals of dimensional analysis. And the third use is that in any given statement, you can easily calculate the formula. Now that is the third use and the last use of dimensional analysis, and the third type of numericals as well. The first is, so we are going to take now third use. So we can make any formula for given conditions. So let's assume we are given that if any force in a circular motion, if any force, let's assume any force is going to depend upon mass, length and radius, then calculate the formula for force. So for this kind of numerical, the step 1 is always going to be very simple. So just write down force is proportional to obviously m, force is proportional to L, and force is proportional to radius r. Now that is given to you. So let's assume any parts. So we are going to take x, y and z parts. So that should be marked as equation number 1. And if you want to have the combination of that, so which means force is proportional to m raised to power x, L raised to power y and r raised to power z, equation number 1. Or you can have a symbol equal to symbol and just have a constant here, so which means m raised to power L x, L raised to power y and r raised to power z. So it is marked as equation number 1. Now step 2 is very simple. Just have the dimensional formula of each and everything. Now force is having dimensions of m, L, T minus 2. Now K is constant here, so no use of constant here, because in dimensional analysis we can't consider the constant. So which means now mass is having power of x and Similar length is capital L now, y, and so that is going to be r. So r is always going to be radius. So which means that is going to be radius here. So you can also have some another formula if you want to calculate force. So then you can have a value of velocity here. Then it sounds more interesting. Now what is velocity? So that is going to be LT minus 1. So we can easily make now formula of each and everything here. So first of all, so MLT minus 2, K as it is. Now combine the values of L, T and R, and which means that is going to be, now M is having power of X and L is having, yes, L is having the power of Y from here and Z from here. So which means Y plus Z. That is very important. Now L is having power of Y from here, L is having power of Z from here, and which means if we are having product of two physical quantities, the powers are always going to be added. So now the time is having the power of minus Y. Now just according to principle of homogeneity. So which means now the m raised to power are going to be equal, which means x is always going to be equal to 1. Now L is having 1 here, L is having y plus z, which means y plus z is equal to 1, and T is having the power of minus y. So which means minus y is going to be equal to minus 2. Now negative negative cancel out, so which means y is equal to 2 here. So which means y is equal to 2 here. Now putting the value of 2 here, so which means 2 plus z is equal to 1 and z is equal to 1 minus 2, which means z is equal to minus 1. Now we have three equations. According to mathematics, if you have three unknown components, then you need three equations to solve that. We obviously have three equations now, and we can solve x, y, z by simple mathematics, and just put up these values in equation 1, you will have your formula. Now therefore equation 1 becomes f is equal to k. Now what is the value of m? M is having power of x, which is x is equal to 1, so 1, and V is going to have the value which is 2, and R is going to have power of minus 1. So which means F is always equal to mv square upon R, and if you can put up the constant value 1, that is centripetal force, the formula is mv square upon R. For a circular motion, you can calculate the value of force from the given condition by that method. So step 1 is just have those physical quantities which in which the given quantity depends upon, and assume the powers, and then make dimensional formulas and make equations in the terms of powers of MLT, and then equate those powers of MLT because of principle of homogeneity. You can solve the value of x, y, z, and then you can calculate any formula by the given method. So that's it. That is all about the numericals of dimension analysis. You can practice many numericals in your book, I think so. Many more are given to you, but these are the three types of numericals which are very important for dimension analysis. Now last not the least is the demerits. Now what are the demerits of dimension analysis? So it's very simple. The demerits of dimension analysis are: first, it's not considering any constant, which means the first demerit is, so it is not considering any constant. K is equal to 1 or K is equal to 7 or K is equal to 5. So nothing will change the dimensional formula. So it's not considering constant, that is the first demerit. It's not considering any trigonometric functions, no exponential functions, and no logarithmic functions. So these are the drawbacks of that. We are not going to consider any constants, any trigonometric, exponential, logarithmic functions, and another is it's only going to consider MLT, mass, length and time. And what about other physical quantities? If a particular formula is having another physical quantities, then it's going to be a problem for us. And one more thing, it's not going to impact with positive negative symbol. If x plus y is equal to k, then x minus y can also equal to k. So the positive negative symbol is not having any impact on the dimensional analysis. So these are the main drawbacks of dimensional analysis. But we have to concentrate on the uses of dimensional analysis, applications and merits. So the first one is we can convert any system unit from SI to CGS and CGS to SI or any other units. And the second is we can check any formula, any relation of any subject, you can say. If you have any formula, any physical quantity, then if you are having doubt on that, either the powers are correct or not, then you can use this tool. You can easily go through the dimensional formulas of left hand side and right hand side. If the powers are going to equate, then the formula is correct. Otherwise, the formula is going to be incorrect. And the third one, under any given statement, you can make any relation or formula. So that's it for today, and like and subscribe and press the bell icon for all to get our upcoming future videos. And thank you so much. Stay blessed, stay healthy. Thank you.